Okay, I'm happy to introduce next speaker. Next speaker is Aliya Korganbekova. Is that right? She's currently assistant professor of business administration at Harvard Business School. She studies financial disclosure in the domain of sustainability and also digital markets. And the amazing thing about her family is, as you can see from the title, all the co-authors are from her family. Her sister is assistant professor of marketing in the Chicago booth, and I heard her brother is also going to be a professor next year. So today she's going to talk about the economics of ranking algorithm. So please join me. Welcome.
Good morning. First of all, let me thank the organizers who are including our project into the program. I'm super excited to share with you our research on ranking algorithms and how they can be helpful for shipping cost optimization. So this is a joint project with my co-authors Malika and Albek. And in this paper, we focus on retail industry and in particular e-commerce platforms. So for these companies in retail industry, shipping costs, especially the mid-mile and last-mile delivery, is considered to be the most inefficient part of the shipping process. Last-mile and mid-mile delivery, what I mean by that is delivering the products to the distribution centers and from distribution centers to the doorstep of consumers. And in total, they account for more than 53% of total shipping costs. And if we zoom out a little bit, and we can see that for companies like Amazon, Walmart, Target, Wayfair, these shipping costs account for billions in dollars, and they are increasing over time. So for many of these companies, decreasing and optimizing these shipping costs has been a strategic priority. For example, if we open the annual report of Amazon, we can see that they explicitly mention that they need to mitigate shipping costs, and they do it through the fulfillment network optimization. And as we can see, there is nothing about the demand changes or anything, and this has been the common approach across the industry companies. For example, building new warehouses, purchasing electric vehicles, dynamic re-ranking, nighttime delivery, and all of these solutions, they are operations solutions. Sometimes they can be very expensive to implement, and sometimes they can be slow to implement. And one common feature of these solutions is that they take demand as given. However, demand in reality changes constantly, and one of the most powerful factors that can influence demand is ranking algorithm. Ranking algorithm is the way the search results are shown to consumers. This is the distribution of products on the grid when we engage with the platform. The ranking algorithms are maximizing the conversion rates. So shipping costs are usually not part of these ranking algorithms. Of course, for Amazon and large platforms, they do include this information into ranking algorithms. However, talking to some smaller platforms, we realize that they do not include shipping cost information when they create these rankings. And the reason is that they are very worried about losing customers. So in this paper, we are asking whether integrating shipping cost information into search rankings can help us reduce shipping costs while not hurting financial outcomes of the company and consumer outcomes. So let's take a scenario. Let's assume that we are shopping on the platform. We see two products ranked as the first one and the second one. And let's assume that the consumer is located on the West Coast. So this consumer will probably choose the product number one because it's ranked higher. And then apparently this product is located in the warehouse on the East Coast from where it will be shipped to the consumer, which is fine. But if we take a closer look, we can see that the second product is actually located in the warehouse also on the West Coast. And it would be much smarter for this algorithm to show the second product on the top of the page for this specific consumer. But it doesn't happen. Why? So there are at least two reasons for this. One is organizational, the second one is technological. In terms of organizational, it depends on the organizational structure of the company. If we think about the companies in retail industry, the way they approach complex problems such as maximization of profit, they do it by decomposition of this complex problem into two sub-problems and solve them separately. For example, they maximize demand first and then minimize the shipping cost conditional on realized demand. And that is why they have two separate teams which are responsible for these two different tasks. Whether this is an optimal approach, we don't know. Based on prior literature, on the one hand, it can be optimal given the constraints that companies face. On the other hand, it might be suboptimal because it can lead to inefficiencies such as lost profit, and we saw it in the example above before. The second reason is technological barrier. If we think about the ranking algorithm, inclusion of shipping cost information can become very computationally heavy for the algorithm because for each consumer product pair, there are hundreds of third-party sellers who can fulfill this order from different warehouses, so it can become very heavy and can negatively impact the page load times. And we know that retail industry is very competitive and they do compete on the page load times. Recent research in industry shows that even 10 milliseconds increase in page load time can lead to reduction in conversions by 2 to 7%, which is pretty material. And before the recent developments in machine learning and artificial intelligence, this inclusion was infeasible for many of these platforms. But now, our proposed approach is actually to jointly optimize these two different problems by putting weights on each one. So maximization of the demand, the purchase probability, and adding a second element, which we call cost penalty. And what this cost penalty means is that it has two features. One is that if the shipping cost is high, the rank of that product will go down. But at the same time, the second feature is that this cost penalty is not uniform. For products that are very popular among customers, the cost penalty will be smaller, so it shrinks with the popularity of the products. To test this proposed approach, we run a large-scale field experiment. We collaborate with a large US retail company, which has more than 5 million products on their website. These are durable products. And they have more than 50,000 sellers, third-party sellers, and which have more than 150,000 warehouses and centralized warehouses that are operated by the platform itself. We can think about this platform as very similar to Amazon, Wayfair, or Walmart, and the goal is just to connect sellers to consumers. So there are two ways how consumers get their products. One is dropship, which means third-party sellers directly send their products to the consumers. And the second one is centralized, which means that the platform has several warehouses across the US, and it's a two-step delivery process. First, the third-party sellers will send their products to these centralized warehouses, and second, from these warehouses, they will be sent by the platform to consumers. But the main feature here is that all the shipping costs are handled by the platform. So consumers are not paying shipping costs, third-party sellers are not paying shipping costs, and this is a platform's responsibility. And that is why shipping cost minimization is so important for platforms who handle all of these shipping costs. In terms of the data, we work with rich data in terms of the scope, so it includes the clickstream data, so we can observe the entire browsing history of consumers. We can see what kind of products they ordered, which sellers fulfilled that orders. And then using the shipping tracking and cost data, we are able to identify the distances that these products traveled. We have the product returns and incidents information, which is helpful for us to identify the consumer outcomes. The data also includes products and seller characteristics, the pricing, the costing, and ranking algorithm details as well. So we ran the large-scale field experiment where first 4 pages of the platform are participating because this is the most popular pages. People rarely go past 4th page. And there are 2.8 million consumers who are participating in this experiment. And this is a whole number of consumers who are engaging with the platform during the period of experiment, which is 8 days in our case. So what we do is we randomly assign consumers into the control group and the treatment group. Control group sees the ranking algorithm, which is business as usual, traditional ranking algorithm. The treatment group sees this new cost-aware ranking algorithm, which not only maximizes the conversion rate, but also includes the shipping cost information. So basically for treatment group, the distribution of the products will be a little bit different depending on the consumer's location. And the shipping cost that we include in the cost-aware ranking algorithm is the normalized dollar cost shipping, value of the shipping cost, which is calculated based on the warehouse location, consumer location, the product dimensions, and also the carrier rates. So again, for each consumer product pair, there will be a vector of shipping costs depending on the third-party sellers and warehouses that can fulfill that order. What we find is that the results are very positive in terms of the shipping cost reduction. We see that the treatment group, which works with the cost-aware ranking algorithm, sees the reduction of shipping cost by 4.8% relative to the control group. And this happens because, as we expected, the products are traveling lower distances and they are fulfilled by centralized warehouses. So centralized fulfillment increases by 12% and products travel at, on average, 34 miles shorter distances. And then the consumers are able also to get their products a little bit faster. It's 1.8%. It translates into 3 to 4 hours on average faster deliveries. There are also some operational benefits in terms of the consolidation. So we don't observe any changes in number of trucks, but we see that the truck sizes decreased by 2.9%, which is great for the road infrastructure because large trucks have negative impact on the roads, such as cracks or potholes, etc. So truck sizes decrease. It also has positive impact on the emissions. But also the platform is able to consolidate better the product that they are sending. So we have full trucks traveling from the warehouses to consumers, and this consolidation improves by 5.3%. As I mentioned before, not only we are interested in decreasing the shipping costs, we also want to preserve the consumer outcomes because companies compete for consumers and consumers can easily leave the platform if they don't like something. So we approximate these consumer outcomes through 3 main variables here. The first one is incidents. We see that they decrease by almost 10%, which is correlated with the fact that products travel shorter distances, so probably less lost packages, less damaged packages. And then in terms of product returns and ratings and reviews, we do not observe any significant change months after the intervention. What it means is that the new products that are offered by the cost-aware ranking algorithm make people happy. They are pretty happy and satisfied with the new selection of the products. So the most important part here is about the financial outcomes of the platform, and we see that while revenue and purchases do not change, the repeat purchases increased by 0.5% during the first 2 months, and the profit increases by 0.2%, which is completely driven by the fact that the revenue don't increase, but then we are able to reduce costs, and costs are the only part of the total cost structure, right? The shipping cost is just a part of the total cost that the company has. And profit increases by 0.2%. But, so overall what it means is that cost-aware ranking algorithm works super well, and many platforms could implement it. However, it's not uniform, so there is a heterogeneity in terms of the results, depending on the category of products and also the locations. So for example, here we can see that non-branded categories of products versus branded categories, they have different outcomes. For non-branded categories, the cost-aware ranking algorithm works super well, so revenues and profits increase. And the reason is because people are more likely to substitute the products when they are non-branded. Whereas for branded categories, the revenues decrease and profit is also decreased, but it's not that significant. And the reason is that if consumer searches, for example, for Nike shoes, they are less likely to substitute with something that is not Nike shoes, and the ranking algorithm just promotes some other shoes. Similarly, we observe that in terms of the geographic location, in some regions it works super well, especially if these are regions covered by the centralized warehouses operated by the platform. And some regions, especially on the West Coast, the results are not that positive. So what are the key takeaways here? What we want to show here is that integrating shipping cost information into ranking algorithms helps reduce shipping costs, but also preserve the consumer outcomes and improve profits a little bit. It has positive impact on marketing KPIs, or at least it doesn't change them. And finally, in terms of generalizability, including additional information into ranking algorithms nowadays can be helpful for better decision making. For example, in terms of marketing solutions, they can be helpful to solve some operational problems, including the assortment, inventory, etc. And I see the generalizability even beyond this. For example, for any other operational problems that companies face, we can send additional information that the companies accumulated over time, and that can be helpful for decision making inside the company. So thank you so much.
Any questions? I have a quick question. Thank you so much for your presentation. So what I noticed that in your data, it's all about like third-party deliveries, like UPS and FedEx. Do you think the results would hold for like the brand-owned deliveries, like Amazon has its own distribution system, Walmart has its own, so do you think the results would change or?
So in this platform we are working with, they don't have the private labels, but I think it still can hold depending on the warehouses where these products are located. Let's assume the platform has private labels, but the warehouses are located in different parts of the US. So it still can optimize based on this location and send the product from the closest one.
Gotcha.
Yeah. So
thank you.
I think it generalizes to that as well.
Interesting.
Whenever you have access to the searches, the actual searches that people use.
Yes.
So whenever you see the heterogeneity in the branded search, is that when they're actually searching specifically like for Nikes, or is it that Nike is getting penalized, but they're looking for, you think that they're looking for those kind of branded products and they're looking for shoes because I want Nikes, not Amazon shoes, right? Mm-hmm. Is it something they're specifically searching for? Are you seeing this effect, or?
So I think there is a variation. Sometimes people can search for just shoes, and sometimes it can be a brand name. So we observe both. Yes.
Okay.
Yeah.
Good.
Do you see any difference in upload times? The CX, I know it doesn't feed into your overall purchase, but when you do this optimization, is there meaningful differences in response time to upload websites and so forth?
No, so that's why I think before this machine learning developments, it was hard, it would negatively impact the page load times, but currently it doesn't have a significant impact. Otherwise, this is the main worry of these platforms. Consumers are impatient and then they just leave to competitors. Now, it doesn't significantly impact the page load times. And it is important because rankings are updated every 4 hours per day for this platform. So it's pretty stable.
Thank you very much.
One final question on that. Did you guys take into account the fact that people are shipping actually in full truckloads? So they're not shipping individual items, they're going to be shipping, the truck is going anyways. Did that get taken into account?
So the consolidation of
Yeah.
we didn't look at this, but we can. Yeah. So for example, for the locations with demand is higher, for example, and the platform already knows that there are similar products that are purchased, then they set the same truck there. But I think it's taken care of by design through this algorithm. But we can take a look at the density of the yeah.
Thank you.